Hey guys. So today we are going to go over some of the basic math stuff. We're going to talk about finding the rotation. So the first thing we're going to do is we're going to review some things from chapter 5, the math. So if you remember, we talked a little bit about mathematically rotating the bearings clockwise. We did a couple of these things, as you can see. Nope, that way, up on the screen here. And so we talked about some of those. So we talked about just when we just do it 15, we only have to add and subtract the degrees. So if we don't do minutes and seconds, then we did the same thing. We talked about in number 22, we talked about rotating past that from one quadrant into the other. That's what we talked about in 22. In 23, we talked about adding them in columns, so we don't have to change to decimal degrees, but we started with decimal degrees, converting it all. We got to 90 degrees southeast or directly east, and then you can see in the green and the pink area we talked about adding that in columns to save a little bit of time. We talked about subtracting and how we subtract things. We have to borrow from them and do that. So if we did it clockwise instead of counterclockwise, what would happen? So we talked about that. So we're going to be doing some of that today. We're going to be adding. We're going to go in the columns because we're not going to switch to decimal degrees. We're going to just make some things a little simpler. But we're gonna give you this some information about finding the rotation of the bearing, because this is on the test, and so there will be a problem like this. So let's pay attention to what we have here. So if we're given a thing, let's talk about what information we have in the real life about finding the rotation. So what information do we typically have? So we would typically have like the section line bearing, so we know what the section line is. We'd have the description's basis of bearings, and then we'd have the actual description. Okay, so we have an example here, and we have, if your description has as a basis of bearing of north 28, 26, 15 east, the section line is 90 degrees on your ownership map. Find the rotation direction and the rotation angle, then rotate the following bearing from the legal description to match the ownership map. North 27 degrees, 18 minutes, 43 seconds east. We can see there that we have the rotation angle, the rotation direction, and the new rotated bearing. That's the stuff we're looking for. So, first of all, let's take what we know out of that thing. Our section line bearing is actually, that's wrong. There we go. Yeah, it's wrong. Those are flipped. So that's okay. I realize that we flipped it. So realize which ones you have. So your section line bearing is actually the 90 degrees east, or that directly east. The description's basis of bearing is that north 88, 26, 15 northeast. And then the description we want to do is the later that we want to rotate is the 27, 18, 43 northeast. So we can draw it out on our little thing here, and so we can get, so how do we get from north 88 degrees 26 minutes 15 seconds east to that 90? Okay, so we have to rotate, and we have to rotate that, and that goes counterclockwise, okay, because we want the arrow to go directly east, and so it has to be, I'm sorry, I said it wrong, it has to be clockwise. Yep, so I said counterclockwise, but I meant clockwise. Yep, so we're going clockwise right there. So we have clockwise. So we have the difference between 90 degrees and 88, 26, 15. Okay, so how do we find the difference between those? Okay, so if we want to know the difference between them, we just subtract. Okay, we're not talking about which way we're rotating. We're not doing that. We just want to find the difference between it. That's what we're finding is the difference. And so what's the difference between 90 and 88? Most people go, oh, that's 2 degrees, you know. So how do we do that? We subtract. So let's actually subtract those. And if we start here, we start with 15, but we can't subtract 15 from 0. So we have to borrow. Okay, did you see that? So we borrowed. So first of all, if we take the 15, we have to borrow, or we have to take seconds, we have to borrow from the minutes. But the minutes has 0 as well, so we have to borrow from the degrees. Okay, so we borrowed 1 degree from 90, which becomes 89 degrees, and we have 60 minutes, because we know 60 minutes is 1 degree. But that doesn't get us all the way, so we borrow that 60 minutes, which becomes, we borrow 1 minute, which becomes 59, and that's our 60 seconds. Okay, so now we can start doing our math. Okay, and when we do our math, we get 60 minus 15 is 45, 59 minus 26 is 33, and 89 minus 88 is 1. So we actually have 1 degree, 33 minutes, 45 seconds that we have to, that's the difference between those two. Okay, so rotation angle, there we go. 1 degree, 33, 45 northeast. That's how we have to, the rotation angle. Okay, so what then do we have to, then what's the last thing we have to do? Find the rotation. We did that. Then rotate the following bearing from the legal description to match the ownership. Okay, now what you don't want to do is you don't want to mix up which ones are which. So you don't want to try and calculate, you don't want to subtract 27 from 88, because then you'll be off on the wrong tangent. You'll do everything. Then what are you going to rotate? 90 degrees, you're going to rotate that, the difference between 88 and 27. So make sure you get the right ones, okay? So if it starts out with, hey, what's your section line bearing? Don't screw up like I did at the first, where you mix them up. You want to make sure you get them the right way, okay? So let's start with another, so let's actually do that rotation, okay? We're going to do that again. Now, see, we're up here, we're going 27 degrees, we're in the northeast. Because we're rotating 1 degree, because we're rotating that same clockwise, because we already figured out we're rotating clockwise. So then if we're rotating clockwise, okay, that means we add. Okay, so we're adding, because remember that in the thing, which is also on the test. Yeah, so if we're rotating clockwise, north, so we add the two together. So 27, we add them up. Okay, then 45 plus 43 is 88. 33 plus 18 is 51. And 27 plus 1 is 28. And we're northeast. So our new rotated bearing, is 28, 51, 88. But you can't have 88 seconds, because that's more, because 60 is a whole minute. We already know that because we borrowed one. So if we're more than 60, so we subtract 60, because we're going to turn that into a minute, and we get 28, okay? Because 88 seconds equals 1 minute, 28 seconds. So we really start with north, 28 degrees, 52 minutes, 28 seconds east, okay? So we've now converted it to everything. We have all of our stuff less, so we don't have more than 1 in each. We don't have a minute all the way in our seconds. And our answer is 28, 52, 28 northeast. Okay? And now Sally at the bottom is happy. Okay? She's no longer confused. She's happy because she knows the answer. Hopefully this helps you find out the rotation of the bearing, and you can figure out exactly what to do, how to find that. You take your point of beginning line, you match it up, rotate it to mathematically to what your section line bearing is. If you're just drawing hand-drawn plats, those are 90 degrees typically. If you're in GIS, they could be, or other electronic form, it could be something else. But that's how we find the rotation bearing. Good luck!